Hello. For those who I haven't met, I'll stay here because I've got the microphone array on the laptop. I'm Nick Williamson. I've been with NI for 24 years. So I started using LabVIEW probably about 1997, something like that. I was quite impressed, so I joined National Instruments. I've been using LabVIEW ever since. Mostly sort of LabVIEW real-time, LabVIEW FPGA, use instruments to a certain extent. Haven't used Python a great deal, but for a long time there's been a sort of, shall we say, a standoff between graphical programming and text-based programming, but they both have very strong strengths and weaknesses. So the idea with this is, okay, well, let's have a look at using the good aspects of both LabVIEW and Python. So as I say, they've both got different strengths. LabVIEW, seamless hardware integration, certainly obviously with our own hardware, but there's a vast array of instrument drivers out there, thousands I think, which have been well developed and can be used for integration onto a larger platform. Obviously we can program our real-time targets for determinism or just for reliability because it's not running Windows. And for those of you who've used FPGAs, it provides, I've got a strange sound coming in at mine. One of the key features in LabVIEW, which people often don't regard when they think about it, is the multi-threading. So it will support multiple threads and multiple processors. As an aside, I did try a year ago. I have an old server running Ubuntu, so it's a quad Xeon, 40 cores, hyper-threaded, appears as 80 cores. So I put the desktop version of LabVIEW on there, 80 while loops with no time delays in, set it running, and 64 of the cores saturate. So the auto scheduler will actually split over 64 cores, but it doesn't take any programming. It used to be an argument against some of the script-based languages, including Python, but Python does actually have asynchronous execution now. Has been for a while, but it is one of the modules that changes a bit each time. And of course, LabVIEW is well known for its graphical user interface. Python, though, has an absolutely huge community of people developing and publishing packages and libraries to do just about anything. Part of the challenge is actually finding the best library in order to satisfy what you're trying to do. Highly portable because it isn't tied to a particular platform, so you can move that Python code. It isn't as fast as proper compiled code. It's probably about 6 times slower, something like that. But for most tasks, that's not an issue. A lot of the things which we get involved with, we're dealing with very fast data acquisition, so you're handling a lot of data, and then it may not be ideal. But again, you may be able to get away with it with Python. There's a huge range of packages and libraries, but they vary quite a lot in how they're maintained. So some are updated, some aren't updated. There was one the other year where the developer was a bit put out, and so he broke a later release intentionally because people were using the library commercially. And so there are challenges. You can't necessarily just update to the latest version of an added module and have it work. And of course, the other big plus with Python is it's free. Because it's so ubiquitous, you've got a lot of people coming out with Python skills. We have seen a drop-off in people coming out of university with LabVIEW skills and so on since we moved away from academia, but we are addressing that. So hopefully we'll see more coming through. So here's a quote from someone at Byte Labs. LabVIEW is still foundational for all our applications, but we started using Python for everything we can't easily do in LabVIEW, like scripting or web applications. We also use it when creating applications on unsupported hardware architecture like ARM for Raspberry Pi, because you can get these Pis in industrial housings now. LabVIEW can be pushed into service when you want to generate a sort of script, but it's hard. it can be a lot easier if you do those parts in Python, and certainly if you're starting to look at perhaps looking at JSON files and dismantling those, or XML, it gets very difficult to do it within LabVIEW. It's far easier to add a Python portion into your code which can actually do that. So use them both together. Now, we've had the Python node in LabVIEW for quite some time. That's 2018 was the first version. And you can point to a supported version as you open a session, tell it what Python script you want to execute, pass the parameters in and out, close the session. The supported version of Python, each new version of LabVIEW, we seem to add 1 or 2, but not up to the very latest. But that doesn't mean that those are the only ones that you can use. It's just that those are ones that are officially supported. You can get away, as you'll see I do on this machine, with using different versions that aren't technically supported. You can also do the opposite. So from if you add LabVIEW automation into Python, you can make calls into LabVIEW and pass parameters. I haven't done this one myself. I think it loads the environment and runs the VI in the environment. So it's not as though you're running sort of object code directly from the VI. It's in interaction with an environment. But one of the nice things there is that's actually modifying those parameters after it's been started. So I'm not sure I would recommend going that route, but if the majority of your application is in Python, that could be a good approach. So yes, 2018 was the first version of LabVIEW with the Python node. Over the years, we've gradually introduced additional support. The big one, which we'll be talking about, and I'll show you today for the 2024 version, was adding the support for virtual environments. The reason that's important is just looking at the version support in different versions of LabVIEW. I'm actually running LabVIEW 2024 Q4, I think, which theoretically only goes up to 3.10. I'm actually running 3.12 on it. So this is the thing, you can run Python outside of this table, but these are the ones which are officially supported. If you're developing an application in Python, you may have different teams doing different parts of the application, or you may just develop them at different points in time. So your duck control, this is sort of interacting with your device. You may have inherited that code from someone else who developed that code some time ago. It's quite tricky to get that kind of thing working. You need particular modules in order to interface to hardware. The data analysis, that's something you're probably updating on a more regular basis. And then you need a nice graphical front end. Now, each of those may be developed either by different teams or just at different times. So you may have Python 2.7, that's quite old now. I haven't seen any Python 2 code for quite some time. Big distinction between 2 and 3. But you may have one in Python 3.6, 3.10. But the important part is underneath those, you've got all of the modules which you have to add in to make them do anything. And as we said, some of the modules change, either the API for them changes, or in some cases they can break. So you can't necessarily take all of that code and move it all into one application. That involves a lot of work and a lot of compatibility checking. So what you can do instead is use one of the virtual environments. Python has the venv function for generating its own virtual environments underneath it. There's also things like Anaconda, which is like more of a management tool for both Python, R, I think it does C as well. That's a commercial package. But using virtual environments, it enables us to wrap these things up so that the modules and the version of Python are isolated. And then all of those can then be called from your application. We already saw that Python node. You can use the Python node to call Python running in virtual environments. So you could run all those three, each of them running under their own version of Python with their own modules, and they all run at the same time, which is nice. So what I will do, first of all, I'll show you how you create a virtual environment if you haven't done it already. How many people here are using Python? It's worth investigating just because of some of the libraries are out there. I haven't written a lot in Python. One of the first things I did was actually using OpenCV2, which is a vision package, because you could interface to simple web cameras. I was investigating looking at the interfacing from that, and actually had it so I was using Python to feed the images across into LabVIEW, and it's remarkably easy. There's some really good stuff out there. What I will do, except I can't get a command line, let me just minimize it. So let's finish this. If you use on Windows, you can use PY, which is the loader, and it'll tell you what versions of Python you've got on your system. So I've got 3.9, I've got 3.12. If I want to create a virtual environment, oh, you can specify the version as well if you want. 3.9, where you want the environment to go. So I'll put it in temp. Look. Leaves that for the moment. So if I then browse Spring file here, file explorer, see. Modified. There's our folder. So basically all it's done is it's created this, and inside the scripts folder, you've got the executables for Python, and there's also a local version of pip. The activate and deactivate batch files basically add the path to that particular environment into your path control. So it's the first one it finds when you type Python. You don't need to do it. If you move into that folder and just type Python, you're running Python in that environment. So that's basically all we do. But of course, this doesn't have any modules installed. So if I wanted modules in here, I have to go into here, run pip to add the relevant modules in. And if you've got a fairly small application, it's fairly easy to do that. And I did that with this one. So I've created a couple of environments on here, one with 3.9 and one 3.12, which we'll be using. And I just tried running the Python code. It errored because a module was missing, so I just used pip to install it. If you go back to that model which we were looking at, where we had lots of different developers with different libraries, they're probably very specific libraries that you need. So what you want is a particular version of Python, a particular set of libraries. And you won't be surprised to hear there are add-on tools for Python which enable you to package all that stuff correctly. And one of the ones which I've used here, I won't run it here, but there's one called Poetry, which will. There are different ways of taking images of the running modules. You could use pip itself, you can do pip freeze, and it will give you all the modules and all the versions, and then you can add it into a requirements file and then install from there. But what you can do with Poetry is you can manage that in exactly the same sort of way, but you can also take that application that you developed and build it, and it will build it into an installable wheel that you can install onto another machine. So you can replicate that whole development environment onto another machine very easily. So it is quite good. but I've already generated these virtual environments. So if we move into LabVIEW just to illustrate the Python calls, too small. So I have an environment which generated from the poetry file actually, which is generated there. Just run it, just check that's working. Should work. Yes. If I change the version, you can see that here's the version that's being used because that will error. There we go. The code underneath this is just a basic code. We can either call Python direct, just open the Python node, so the version and its path, the path to the thing, and then pass the module, the Python file that we're trying to run into that, executes, and then it ends. If you run it in a virtual environment, it's almost exactly the same. It's just your Python reference is now coming from another location. Doesn't require anything more. The other one in here, quickly show you. This is something that we added in 2023, I think. If we look at the block diagram for this one, we're opening it in a virtual environment. It doesn't have to be, but we're running a piece of Python code from that particular module. But we're also passing in a Python object reference, and that Python object reference comes out. So this executes the Python code. Python code modifies that object. That object can then be passed into another Python call. So you can have persistence of an object between calls. Whether that would work between different versions of Python, I don't know, probably. I think it should. You'd have to experiment with that. So what all this one's doing is we're load the first call is loading a number into that object, and the second one is adding to it. Remarkably, 4 plus 5 is 9. So we move. If you look at a typical workflow, you have the duck control. So you may actually have scripting as part of that or above that in order to control that, but it may be loading something in for a test. You've got the data acquisition, so see we're familiar with that, because that side of things. Logging files, logging data, shall we say. So it could be tag data, it could be fast waveform data, could be anything really. And then analyzing that data. Quite often that analysis actually comes in between the acquisition and the logging, because you maybe wanted to do that very quickly. What we're suggesting here is a particular instance may have a setup like this. You may have Python for the control of the DUT because there are particular libraries available for that particular device. The acquisition makes sense in LabVIEW because it's designed to deal with that hardware interfacing. Logging, again, within LabVIEW because we've got the raw data. Analysis, that may be done after the fact, so that might be a post-acquisition activity. And that's a point where Python can come in, again, because of some of the extensive libraries that are available for it. It is a bit slow, though. So if you're looking for fast processing, I would argue you're probably better trying to keep it in LabVIEW if you can. And if you pipeline your code properly, you can be doing that while you're doing the acquisition. So the whole thing's making efficient use of the machine. The number of people who record all of their raw data because they think they may need it one day, it's far better to extract the value at the time and not record the raw data. People's hard drives are just filling up with data and they don't even remember how they've acquired it and what the data is. So if we show That one? Not that one. What's in that one? What we have here is a compact deck. Got a analog in, analog out, just loop between the two. They're actually going through a small router, partly so I could get in an external connection, but also I can everything's set up on DHCP. And then I have a couple of VIs here, which hardware reference. That's okay. All this is doing is generating, well, we open the block diagram, you can see what it's doing. What we're doing here is we're opening a virtual environment, one of those ones that we've already created, and then we're setting up an analog output task. We're then calling Python to generate that waveform data that we then write into our analog output. And then we start it, if it hasn't already started. And this goes around just generating waveforms. If you look on the front panel, now referring to, there's that virtual environment I created. This one's in 3.9. So that running, you should get waveform generated. There we go. That's now generating from that one. And at the same time, open a second VI. I can find the project. There it is. And if we look on this one is doing something similar. Again, we're opening a virtual environment, getting it ready, and then we're setting up an analog acquisition task. And that one is going to acquire data and push the resultant data out into some Python code to do the analysis. And then all we're doing back here is just breaking out the data and displaying it on the graph. So if we move back to the front panel, oops. And this one's running in 3.12. There we go. Can't keep up with hardware. This is because I've got the Python code in there, which is a little bit slow, and I have a particularly slow laptop. It should keep running. There we go. There, if I change freaks on here, you may even see a change in here, but this may need to reload. But essentially, that's all there is to it, to interacting with Python code using the Python node. Sharing data, people often talk about Python for generating sort of web content, that kind of thing. We used to have various tools within LabVIEW, so the embedded web pages, that kind of thing, which were a nice quick way of doing things. Unfortunately, they were based on technology that went obsolete, so that doesn't work anymore after 2020, I think it is. So our approach now would be either running a local display, or you probably publish using web services and then develop an application which can interact with those web services for the display side of things. What we were doing in all those cases there, pretty much all those cases, is we're running a piece of LabVIEW code and we're then effectively transferring the execution flow across to Python, waiting for the response, and the data comes back. One of the other things that you can do is use gRPC for the data communication between Python and LabVIEW, or between Python and Python, or between anything else and either of those targets. So this is remote procedure calls, and the gRPC is Google's implementation of remote procedure calls, which they then made public. it does involve a server running somewhere. So you do need to, essentially underneath the various drivers, you end up with a DLL as a service that's running that can interact with the clients that are connecting to it. So it's not truly portable in that sense. You do need something for the specific target. But we do have gRPC in LabVIEW, and it's used in, if you've seen Instrument Studio where we have the measurement plugins, that's done using gRPC. And the reason for it is partly you can have running processes and interact between running processes using gRPC. So it's not, you're not interrupting execution flow waiting for a response. You can have two completely separate processes and then intercommunicate between them. The other thing, of course, is that gRPC link may be between two processes on the same machine using localhost. Doesn't have to be. You could have that link into a running executable elsewhere on the network. So it's a really good way of providing potential for expansion. But in order to set up that communication, you have to define the proto file, and then the toolkit in LabVIEW, you actually have a gRPC tool which will take that and create the various VIs in order to do the communication between them. You'll find that a lot of the downloads and things are all on GitHub, so it's not an integral part of the applications yet, but it is a standardized interface. So there are tools in Python as well for doing the same thing, for generating the same calls from the same proto file. If I jump to one of the projects, here we have a gRPC based application. We have a client and server. So I can show you what they look like. Oh, yeah, that's right. So on the server side, if we look at the diagram, this is using the VIs which generated from the toolkit. Basically, all it's doing is creating a connection with then passing that the server sits there running, waiting for a client to connect. The client will then connect to it, pass a name over, and it'll then respond. It did. One of the things which doesn't, you've got to watch with some of these references, localhost doesn't always resolve correctly when you change your network configuration. The other thing, if you are going to use security on this and add certificates to the server, bear in mind the certificates are usually tied to the machine names and not the IP. Although the certificate can list IP addresses as well, sometimes the domain name resolution can be an issue in order to be able to set up the security between endpoints. The easiest way I found to generate certificates is actually using window, the WSL window. Does everyone know about the Windows subsystem for Linux? Yeah, so you can basically run a Linux window in Windows. You can then put OpenSSL on there, and then you can generate certificates from there. That seems to be the easiest way of doing it. We're talking about publishing, providing web service based data for the graphical user interface, because we don't have the embedded web pages anymore, and you may want to integrate that information with data coming from other sources. So we have web services in LabVIEW and in Python, but this is just a mention of the gweb development software, which we provide. It looks a bit like LabVIEW. It looks a bit more like LabVIEW NXG did actually, but it enables you to create something which is a bit like a LabVIEW front panel. But what it does is it creates an HTML5 page, which you can host somewhere. The client machine will then use that page, render the screen, and of course it's then the client machine that has to request the information that's then coming from those web services, wherever they may come from. So we do have a tool that can create very nice graphical interfaces that will then work on anything. Anything HTML5 aware, so any modern browser, be it on a phone, a tablet, PC, Mac, anything, you'll then be able to bring up that graphical interface. So it isn't necessarily a case that any particular tool should be used in order to publish that data. Anything that can publish that data as a web service is a good source of data for generating those remote front panels. If you can run a local front panel, then so much the better. That isn't always the case. The GWeb software is, it is included there. I assume you've seen the various marketing to do with LabVIEW Plus. We did for a time we had this test workflow name which was used, which was a collection of different pieces of software. The idea with the LabVIEW Plus suite is basically it's a suite which wraps most of the common tools into one license. So we have LabVIEW, we've got Instrument Studio, so it's the environment for interacting with modular instruments. FlexLogger, which does the same kind of thing but for data acquisition. Even if you're used to using LabVIEW, have a look at FlexLogger because it's a really quick way of just quickly getting up a logging task and letting it run. It saves a lot of effort. Diadem for all your offline data analysis, Testam for sequencing, and then the GWeb development software for generating a graphical interface. So this is sort of where we're trying to direct people so that they have the suite of tools. It doesn't include everything, so we haven't got Veristan in there, things like that. If you're looking for doing hardware in the loop, you may want to put the pieces together separately. But it is a good cohesive group of software which can interact easily. What we'll do after this is generate a PDF. So you've got the links which we've got on this page, which gives you links into other more detailed information